What we're going to take a look at in this video is going to be summarization with EIGRP and exactly how that would come into play in the environment. So we've already taken a look at summarization to some degree already with default routing and stuff like that, but I want to take it a step farther with a leak map. We want to take a couple of routes on R11 and advertise them out, and we're going to advertise two different versions. So for one, we're going to want to have traffic coming from for a particular route going this way, and then another particular route coming in this way. And the way you would do that is by simply going into the routing protocol and advertising a prefix list, calling that prefix list by a route map, and that's how you're going to use it for the leak map configuration. But what we're actually going to do is we're going to advertise in the actual prefix list. We're going to give a /28 versus /27 and see exactly how that would work with the advertisement. Now, when you're doing this, the key thing to understand about it is when you're advertising it, you want to advertise out the interface that you want to prefer it on. So if you want, and by me saying that, if you can use a summary without the leak map, and if, let's say for instance, you advertise the leak map or the summary out this way with no leak map, then this will be the preferred route, because of the fact that the summary is going to shorten the match, which means it's going to be less preferred. The longest match routing is going to choose the longer match to go there. Now, if you advertise a route with a leak map with the summary route, and say the summary route is /20, but you advertise 1/27, and that's how it goes out this way. But then you advertise that same route out this way as a /24, it's going to come back in this direction. The reason for that is because it's a longer match. That's going to be the key thing. Now we're going to take a look at this and see exactly how this plays out with a couple different variations, and see exactly what does better, how it does, why would it do better than X, why would it do better than Y, and that's going to be the key thing to understand is why things work the way that they do. Because if you understand all, my intention is to look at as many solutions as I can possibly think of, because the more solutions I can think of is going to be something that's going to trigger in my mind when it comes down to getting things operational in the lab. So remember, you only have 5.5 hours of configuration, so there's not going to be a ton of stuff that they're going to be able to throw at you. But it's definitely possible to get some interesting issues that'll crop up on you in the lab that might, prove to be challenging to get operational. So the first thing we're going to take a look at is on R11. So the first thing we're going to do is take a look at show IP interface brief. And we want to advertise two loopbacks. We're going to advertise config T. We're going to advertise interface loopback 100 is going to be IP address is going to be 172.16.100.11 with a 24-bit mask. And then we're going to type in interface loopback 200. IP address is going to be 192.168.200.11, 24-bit mask. And then we're going to do a do show run pipe section EIGRP. See exactly how this is routing, or see exactly what's being advertised. So right now just the 10 network is being advertised. So we're going to go to global config. I'll redistribute connected, so it's automatically going to get kicked out. So let me go to router EIGRP1 and type in no redistribute connected, and that'll take care of that problem. So now what we're going to do is we're going to type in network, and we're typing 172.16.0.0, 0.0.255.255, and same thing with 192.168. The reason why we're doing that now instead of later is because I don't want to have to sit there and keep advertising networks in. If I want to just advertise a few more routes in, that'll give me that capability. Then we're going to go to R18 and do a show IP route, and we should have the 172.16 network in, and we do, and same thing with the 200 network. So that's good. So we're getting routes in. That's what we want to see. So now what we're going to do is we're going to go to R11 again, and I'm going to exit out of here. I'm going to type in IP prefix list. The name of it is going to be shorter match, or I'll make this one be the /27. See if that'll actually work for me. Oh, it does. So /27 is what we're going to advertise. There's a question, even though you're advertising a 24 via the network statement, can you advertise via the prefix list to be that short, or be longer than what's advertised? I don't know. I'm going to try. I'm going to permit the 172.16.100.0/27 unrecognized command 0/27, and I'm going to hit enter, and I'm going to type in route dash map, and I'm going to say this is going to be the we'll say shorter match, and we're going to say match IP address in prefix list /27, and hit enter. Now I'm going to go to router, or no, we're not using, it's going to be interface gig 1/0. We'll type in summary address, or IP summary address for EIGRP1 is going to be, and we're going to say the summary address is going to be a 172.16.0.0 and /16 with a leak map of shorter match, and that's how we're going to advertise that out. Okay, so that's being advertised out this way. So it's going to reconfigure, and if I was to go to 18, let's see, is it going to show up? Yes, it does. Before it was coming through both of these guys. The 172.16, it was coming through both. Now it's coming through 20. Now it's just coming through 20. So we're going to trace route to 172.16.100.11. We're going to trace route to 20. Now is that the preferred route? Well, no, it's not. So because we advertised a /16 to 19, now see, I don't think that's actually working correctly because of the fact that we have the /27. So let's do this on 11. Let's actually modify the prefix list. So we're going to type in IP prefix list, this guy, but we're going to say /23 instead, and hit enter. Then we're going to go to 18, and we're going to do a show IP route, and we should get, see if anything has changed. Let's do a clear IP route star. It's still being preferred that way. So the idea now would be to go to 11 and let's see here. We're advertising it out. Summary address. Gig 1/0. So we're advertising it this way, but it's preferring this route. And that's because of the fact that we're advertising a /16. So if we were to take the summary address and make that a little less, let's do the summary address. If we didn't make that a /16, we would make that a /20, and hit enter. And then we go back to, and then let's go back to 18 and show IP route. Let's see here. Still preferring it to be a route of 20. Oh wait, no, it's okay. So here's the thing. If we go to say anything /16, it's going to go via 19. Or anything via via the longer match, this 24 is being preferred via route of 20. So if we were to go to, let's say on 11 and do a and notice how by changing the shorter match we got it refreshed. So if we were to do a, let's see here, just trying to think. Well, actually that proves it. On 18, that does prove that it's working because we advertised a shorter. Actually, let's see if that changes anything. Yeah, so it's advertising the /16 via 19. So it's advertising that, and then we had It's actually not correct. It should be. Oh, you know why? Because it's going to advertise, because that's EIGRP. Because it's going to advertise it that way anyway. So, because we have a 101/8, even though we have /27s coming through. If we have the 172.16, so one's being preferred this way, this one's being preferred that way. So 19 versus 20. So theoretically speaking, it is working. Now that's how you would prefer traffic engineer. So let's say, for instance, we want to make sure that we're gonna on 18, we want to let's go to 20 and say, are we doing a show IP route? Let's go to 18, and we're going to advertise a default route on 2/1, and actually we'd have to do it on 20. So what we'd do on 20 is we'd have to advertise a route to 11 to say, hey, if you want to use me, you have to use this match to get there. That's how that would come into play. Now, that's probably the easiest way to do it, as long as you use a leak map to do it. So just remember, prefix list is going to, you create a prefix list with the route that you want to advertise. So you want to advertise, let's actually on 11, let's make this, let's type in interface loop 101, and we're going to type in IP address is going to be 172.16.101.11, and it's going to be a 2224. So that's what we're going to advertise. So we actually have a legitimate route to that. So now, since we advertised in EIGRP, correct? Yeah, we advertised anything we want into EIGRP. We're going to go to 18 now, and then do a show IP route. So we're going to get the /27 in now is being advertised via 20, but the /16 is being advertised via 19. Now if we trace route to 172.16.101.11, it's going to go via 20. But if we advertise anything shorter than that, so like 172, let's advertise, and this is 100. So if we advertise anything else, now the problem with this being is it's being advertised. So let's do this. Let's go to 11 and type in interface loopback, 102. But we're going to type in, this is going to be IP address is going to be 172.16.0.11, and then it's going to be a 24-bit mask. And then we're going to go back to 18 and do the up arrow, and we're getting now, since we're advertising there it's coming in now. Since we are advertising a 24-bit mask, but it's a 0 range, now we're getting these other matches in. So we're going to do a trace route to 172.16.0.11. We're going to go via 20 to get there. So they're all going via 20. And the summary match. So the summary match is going to be, if it's anything 20 or 20, it's going to go via 19. If it's a 16, it's going to go that way. So if we go to 11, we do an interface loop 103. And we type in IP address is going to be 172.16.0. Or actually we'd have to do, we'll say 1.11, but it's going to be a 20-bit mask. 102. Alright, let's go to 102 and then modify that one. Alright, so that'll take care of that. We'll go to 18, do the up arrow, and so now we're getting these two routes in here for the 20/20, because we have 20 routes. We're going to do a trace route to 172.16.0.11. Now we're taking both paths. So depending on how long your match is, will determine whether or not how you're going to route there. So it does determine, based on how things are being forwarded, how that comes into play. So you can mess with your routing table a lot if you really want to, but that's the key thing to understand what it is you're trying to accomplish. So I think it was on 111, so that's what it was. So it knows how to get there, and the reason it knows how to get there is because of the fact that we advertised, I broke out of it already. Since we had the 116.0/20, anything that falls inside of that range is going to be routed via 20 and 19. Since it fell inside that range, because it isn't a well-known address, so we said 1.11, we know for a fact that it's going to use both routes to get there. It does get to its destination because it exists. We don't have a route that points to this address. So it'll still get across the network regardless. So we'll still get to 11, and 11 will receive it in and go, well, I don't have a destination for 0.11. I don't have anything configured. So and how you would know that is if you were to do a jump out of here and do a show IP ceph for 172.16 slash I think 20 is what you would. Is that 172.0.0 with a 20 255.240.0. It's attached to loopback 0. But notice how this range is 172.16.20. So that's where it comes into play. So you, technically speaking, if you were to look at a show IP ceph and whack all this stuff out of here and scroll down to, so we have attached right here. It's going to take it in, but there's nowhere for it to go. There's actually no destination address with that stuff set up on it. So that's why on 18, that's why we ended up going nowhere right here. So as you can see over, just by tweaking some things and messing with your longest match routing, and we didn't actually mess with anything inside of the prefix length. We could modify the prefix length and say anything /20, but see, it's not actually going based off of that. It's going based off the summary. So we're going to do a show run interface gig 1/0. It's going based off of wrong router. Show run interface gig 1/0. It's going based off of the summary address, and actually there's two here. So if I was to go up and now the question is, which one do we want to pull? Since we're receiving both. We're receiving both the /20, which is the if you were to look at this, /16 is this guy. So we're receiving both, and we are also receiving the /20 on both. So we're actually receiving both. If we were to go in here and mess with this, it would pull out, let's say for instance we want to pull out the /16 and make it a longer match. So then we can go to 11 and go to config T and type in no, and take this guy and go wackadoo. Oh, interface gig 1/0. So that would take care of that. Now 18, that's going to resync. We're going to do a show IP route, and so that removes the /20. Now we're going to have the /16 is going to be variably subnetted, and then we have the route to that. So now if we type in, do a trace route to 111, it's going to use both paths to get there. But if we had a longer match, if we wanted to go to say the /20 or /24, we could say we want to go to, trace route to one of these other longer addresses. It's going to use, it's going to use both now. I mean, I don't know if I like that or not. What's my summary saying? Shorter match is going to be show IP prefix list. So I've got a /23 and a /27. So we're going to actually go up and go to config T IP prefix list. Let's actually do this. If you type in this, or no sequence sequence, and we'll say 10. We want to pull the 27 out. We could do sequence 5, control A, no, that should pull it out. Sequence 5, oh yeah, sometimes it just bugs you. Permit that. Okay, so now when we go to 18, that I don't think that should regenerate because we're not modifying the summary address. But if we do a show IP route, That's alright, so that takes care of that. Now we're just getting the /20. We're not getting the /23. So it's not even matching anything. And you know, I bet you the reason why it's not getting anything is because we don't actually have a route that's actually matching that. So if we were to go to 11, and we have a /23. So let's configure /23, and we're going to go to interface loopback 105. We'll type in IP address. It's going to be 172.16.100.105 with a 24-bit or 27 or 23-bit. So that's going to be a 254.0. Then we're going to go over to 18 and then do a show IP route, and there we have the /23. Because we have so there's got to be a route in the routing table for it to actually to trigger, and so now we have these routes in here. So we're going to do a trace route, and then what's going to end up happening here is they're both going to go trace route to 172.16.10. Was it 105? Yeah, 105. 5.11. They're going to go over both paths to get there. But if anything goes, they're going to load balance across. So we've got multiple different ranges, and you have to have a route in the routing table that's going to actually pull that. So that's how that's going. Now, if we wanted to prefer something, we could either go on gig1/0 and make a on this one right here. We could either make a change on this to make it worse, or we could modify something on this guy to make it worse, or this side. So the delay, we could modify the bandwidth. We could, you know, the shorter match obviously is going to, the longer match is going to win with just about anything. So if we, I'm trying to think here off the top of my head, it's actually advertising in addition to. So these all fall into the same category, right here. So because they're all 172.16, it follows underneath that. Now if it goes somewhere where there's not a route, let's see if we can find that. So it gets to, so it still travels to router 11, but router 11 gets it, doesn't know what to do with it. So there's what they would call there's no valid glean adjacency in Ceph. So that's why it's happening. So, but at least you see how this would actually come to play. So play around with it. Definitely check out how something would work and get operational. I hope this has been informative for you. I'd like to thank you for viewing.